Hello, students! Yay, math! All right, so how do we prove two triangles are congruent if it's on a graph? Well, this will be a little bit more difficult. Um, One of the first things we can do, though, is right off the bat, we do know that CD is congruent to CD. That's by the reflexive property. They are back to back, so that's that. We get that one for free. Now I'm going to show you lots of things we can do here. So one of the ways we can prove these triangles are congruent is by using the distance formula. How long is AD? How long is BD? We're going to do that. So AD, so A right here is 0, 4. D is 6, -3. So the length of AD is, x1 minus x2, 0 minus 6, squared. Y1 minus y2, 4 minus -3, squared. And I'm going to work this out. So that's going to give me -6 squared would be positive 36. 4 minus -3, that's going to be 7. 7 squared is 49. And then when I add those together, that's going to give me the square root of 85. Now, you can just leave it like that. That's perfectly fine. Or you can type into your calculator. So the square root of 85 is 9.2195. 9.21954, and it keeps going. I'm going to do the same thing for BD now. BD, well, let's see here. B is at 8, 6. So once again, we do the distance formula. x1 minus x2 squared, y1 minus y2 squared, and then add them and take the square root. So 8 minus 6, well, that's 2 squared, which is going to be 4. 6 minus -3, that's going to be 9 squared, which of course is 81. And that's going to give me square root of 85. Hey, same thing. Fantastic. Now I can come right underneath this and say, since AD is the square root of 85 and BD is the square root of 85, that means AD is congruent to BD. So we got those sides congruent. Fantastic. All right, excellent. So that's another pair of things congruent. Another thing we can do here is, so we could do the same thing to figure out the distance from B to C and from C to A and do it that way. I'm going to show you a different way though. I'm going to say C looks like the midpoint here. So let's check. The midpoint of BA is going to be, so I add the x's and divide by 2. 8 plus 0 over 2. Add the y's, divide by 2. 6 plus 4 divided by 2. Well, that's going to give me 4, and that's going to give me 5. Hey, that's what C is. So C is the midpoint of AB. So now that I know C is the midpoint, I can use that and say AC has to be congruent to BC. Because C is the midpoint. Now that is technically enough information to prove the triangles are congruent. I've got one pair of sides, two pairs of sides, three pairs of sides. If all else fails, you can just do side, side, side. Do all three pairs of sides to prove the triangles are congruent. You can do the distance formula all 3 times. No, it'd be 6 times because you got to have 3 sides. But on this one, I'm going to show you one other cool thing we can do. And that is, I'm going to find the slope of AB. Slope of AB is up 1 over 5. Up 1, no, not up 1 over 5. Up 1 over 4. Up 1 over 4. 1/4. The slope of CD. I'm going down 1, 2, 3, 4, 5, 6, 7, 8, and over 2. -8 over 2. That's the same thing as -4 over 1. Hey, those are opposite reciprocals. That means AB is perpendicular to CD. That's fantastic. Well, if AB is perpendicular to CD, we know perpendicular lines make right angles. I'm going to call this angle 1, this angle 2. So angle 1 is right, angle 2 is right. And if they're both right angles, they're both equal to 90, so that means angle 1 is congruent to angle 2 because they're both 90. All right angles are congruent. So now if I wanted to, I could do side angle side. I could do hypotenuse leg. Or hypotenuse leg. So all these different ways to prove that these triangles are congruent. I'm just going to stick with these 3 over here and say triangle ACD is congruent to triangle BCD by side, side, side. And then, of course, if I wanted to, I could say, well, since the triangles are congruent, that means angle B is congruent to angle D. Because the triangles are congruent, I can prove that these angles right here are congruent because the triangles are congruent. And if these angles are congruent, that means this is an angle bisector. All sorts of wonderful things we can do once we know the triangles are congruent. But all you do is prove the triangles are congruent, so we're finished, and we put down QED, quod erat demonstratum. It has been demonstrated. All right, so you can use the distance formula. Sometimes you might be able to use midpoint. Sometimes you might be able to use slopes to prove things are perpendicular or maybe parallel. That could be good too. Maybe get some alternate interior angles that way. But that's how you prove triangles are congruent using the coordinates. Make sure you show all the calculations. Thanks for watching.